k nearest neighbors or KNN is a simple non-parametric classification or regression algorithm. It classifies new data points based on the majority class of the k nearest points in the feature space. It's particularly useful for smaller data sets where the relationship among data points can be easily visualized. Let's go ahead and implement a line by line code for implementing k nearest neighbors in Python. So first, let's go ahead and import the necessary libraries. First, we'll need from sklearn.neighbors import kneighbors classifier, which imports the kneighbors classifier class from scikit-learn's neighbors module. This class implements the k-nearest neighbors algorithm for classification task, where the model classifies data points based on classes of the nearest data points. Next, from sklearn.model selection, import the train test split. This imports the train test split function, which is used to divide the dataset into training and testing sets. This helps in evaluating how well the model generalizes to new data. Next, we have from sklearn.metrics import accuracy score and confusion metrics. This imports the accuracy score for measuring the overall accuracy of predictions and confusion metrics for a detailed breakdown of the model's performance, showing counts of true positives, true negatives, false positives, and false negatives. And then finally, we'll import numpy as np, which imports the numpy library, which provides support for numerical operations and array manipulation in Python. Next, let's get the sample data. Here we are using hours studied and prior grades versus pass fail. So we have the x equal to np array, which defines the featured data x as a numpy array where each sublist contains two values. First value represents hours studied by a student. The second value represents prior grades, example percentage. Now x has the shape of 10, 2, indicating that 10 examples with 2 features each. Next, we have y equal to np array. This defines the target data y as a numpy array containing binary outcomes. 0 for fail and 1 represents pass. This is a binary classification task where we aim to predict whether a student will pass or fail based on their study hours and prior grades. So let's go ahead and split the data into training and testing sets. We can do that using train test split function. This splits the data into training and testing sets. We get xtrain and ytrain used to train the model, and xtest and ytest, which is used to test the model's performance. Our test size, as usual, is specified that 20% of the data will be used for testing, while the remaining 80% will be used for training. A random state equal to 42, which sets a seed for reproducibility, ensuring that each time the code is run, the data is split in the same way. Next, go ahead and initialize and train the model with the K3. So to do that, I can specify model k neighbors classifier n neighbors equal to 3. That initializes a k nearest neighbors KNN classifier model with k equal to 3, meaning the model will classify a new data point based on a majority class among its 3 nearest neighbors. You can increase it, reduce it, up to you. Next, we have model.fit xtrain ytrain. This trains the KNN model on the training data xtrain and ytrain. KNN is non-parametric model, meaning it doesn't learn a specific set of parameters. Instead, it stores the training data to make predictions based on the nearest neighbors. Next, go ahead and make predictions. So I will use ypred model.predict xtest. Uses the trained KNN model to make predictions on the test set xtest. The model classifies each data point in xtest based on the majority class of its 3 nearest neighbors as specified by n neighbors equal to 3. The output ypred contains the predicted classes, which is 0 or 1, for each data point in the test set. Next, let's go ahead and evaluate the model. Accuracy equal underscore score ytest ypred. This calculates the accuracy of the model by comparing the actual values ytest to the predicted values ypred. Accuracy is the ratio of correctly predicted instances to the total instances in the test set. Next, we're going to do the confusion matrix, and this computes the confusion matrix for the model, showing a breakdown of true positives, true negatives, false positives, and false negatives. This helps to understand the model's classification performance in greater detail. Let's go ahead and print the accuracy out and then print the confusion matrix out. Now, this code demonstrates a full workflow for training and evaluating a k nearest neighbor classifier. The KNN model predicts binary outcomes based on our studied and prior grades, showing how it classifies each test data point by looking at the classes of the nearest neighbors. Let's go ahead and run it. Open my terminal, say Python k nearest neighbor, run it, and we'll get the output of accuracy and the confusion matrix here. Now, if you have any problems or had any issues or have any questions about this, let me know and I'll get back to you.